Okay, welcome back to the second goal of section 4.5. The second goal in the book is examples 3 through 6. So hopefully you're following along in your book. Let's go through. The first concept of this is actually completing the trinomial as a perfect square. So then rewrite it as a perfect square. That's kind of the first step to this. And example 3 is exactly like what this is all about. So when you have a trinomial, you don't know what that last number is, okay? And so the idea on this is to complete this trinomial to make it a perfect square, okay? So to do that, you know you have to rewrite it as a perfect square, so we're actually going to do that first. We're going to rewrite it as a perfect square, assuming we will fill this in with a number to make it equal, okay? So for example, since this one is going to be a perfect square, I know this number is half of 12. So I know plus 6 has to go here. Otherwise it wouldn't work. Now, this first part is not equal to this unless we square this number and put it up here. So what I've basically just done was I've completed the trinomial as a perfect square and I rewrote it as a perfect square. These two things are equal now. This squared is equal to this, okay? So that's what we're doing. All right, so this next one, it's kind of nice when you have even numbers in the middle. Okay, we're going to rewrite it as a perfect square. This is half, so x minus 11, because half of negative 11, of course, you have to have a negative. But then when you square it, it's going to be positive. Because you square a negative, it's positive, so this is 121. Okay, so if I erase my arrows here, I've got x squared minus 22x plus 121 is the same as x minus 11 squared. It's written as a perfect square. Okay, now, when you have an odd number in the middle, I would like you to use fractions. Try not to go to decimals right away. There are so many students want to use their calculators, but you don't need to. So stay away from the calculator as much as possible. Okay? So what I would like you to do is do exactly the same thing. Half of 7 is 7 halves. So x minus 7 halves. We're going to leave it as a fraction. When we square a fraction, we square both the top and the bottom. So that is going to be 49 fourths. There we are. We have a perfect square trinomial written as a perfect square. So try not to use a calculator. Try not to go to decimals. Leave them in fraction form, and you'll see why later. Okay, here we actually have a fraction in the center, or the B number. And so what we're going to do here is we're going to do exactly the same thing. Do not change your method. Okay, so we've got x squared plus 3/4 x, so we're going to take half of 3/4. Well, when we take half of 3/4, you either double the denominator, which makes it half, or you take half of the numerator. In this case, since the numerator is odd, we're going to double the denominator, so x plus 3/8. 3/8 is half of 3/4. Square that, we get 9/64. Okay, so that's completing the square. Very simple, very easy if you know how to do this. Okay, so you need to practice. All right, next one. Half of 2/5. Well, since the numerator is even, we're going to just take half of it. So x plus 1/5. And of course, we square that, we get 1/25. Okay, so there's how you complete that one. The next one, we have an odd number on the top, odd number in the bottom. So what we're going to do is we're going to just double the denominator to get half. Okay, so we get x minus 3/14 squared. When I square 3/14, I get positive 9 over 196. And that's how you complete the square. Okay, so let's use that to solve. Okay, so like I said, number 3 is just like that, just written a little bit differently. They ask you for the value of c that completes the square. So you're basically doing the same thing we just did over here, where you have x squared minus 14x plus c. Rewrite it as a perfect square. We know that x minus 7 squared, so c has to be 49. So the two answers that you're going to have, c is 49 and x minus 7 quantity squared. Now that's the example that we used for the concept I just showed you. This is where you're going to start actually solving it using this method. We've kind of built up how to solve it and how to complete the square. Now we're going to use completing the square to solve. So here's how you do that. Example 4a is exactly what you're trying to lead up to and accomplish here. All right, so what we're going to do first is we want to set the left side up as a perfect square. So I'm going to go ahead and get rid of the 24. We don't need that there right now. All we want there is x squared minus 10x plus some number equals 24. So we're going to leave a space here because we're going to fill that in. We're going to fill that in with completing the square. Okay? Then we're going to rewrite this as a perfect square. I'm going to leave the 24 off of here right now because you'll see why in a second. Okay, so what I did here was I'm going to reset this up as a perfect square, so I know this is x minus 5. Remember, half of this, and I'm going to square it. So I need to add 25 here. This should be a minus 24, sorry about that. We're going to add 25 here because that makes this now a perfect square, and it can be written as x minus 5 squared. Now, I cannot just add 25 to the left side. I must also add 25 to the right side to keep the equation balanced. Okay, as long as I keep the equation balanced, I should be able to now just simplify. I simplified this as a perfect square. I'm going to simplify this as positive 1, negative 24 plus 25. Okay, now I can solve it using completing the square or using the square root method. If I take the square root of both sides, plus or minus, I get x minus 5 equals plus or minus 1. Square root of 1 is 1. X minus 5, oh, sorry about that. So when I add 5, again, x is equal to positive 5 plus 1 and positive 5 minus 1, which is 6 and 4. So according to this, my two solutions for this equation are 6 and 4. Now this is a very simple equation. You actually could have solved this one by factoring very easily. However, we're learning a process here of completing the square because when the equations get a little more challenging, you need to be able to show those steps and use this process. Okay, let's go over to 4b and do exactly the same process. So let's go over here. We're going to subtract 9 from both sides. We get x squared plus 10x, and again, I like to leave a space here, equals negative 9. I'm going to make this side into a perfect square. By doing that, I know this is going to be x plus 5 because of half of 10. So I need to add 25 to both sides. Negative 9 plus 25 is 16. I'm going to then take the square root of both sides. I get x plus 5 equals plus or minus 4. So my two solutions are minus 5, so negative 5 plus 4 and negative 5 minus 4. So my two solutions are negative 1 and negative 9. So x equals negative 1 and negative 9. Those are my two solutions. You can always put them back in the original problem and check to see if they work. Again, this one would have been very easy to solve by factoring, but that's not what we're learning right now. We already learned factoring. So let's go ahead and try 5a. Now, here's another something detail you need to be careful of. When you have an x squared coefficient other than 1, so in other words, this is a number other than 1, so we need to take care of that. We want to get that back into a 1. Now, to do that, what you do is you actually get rid of it by dividing everything by 3 on both sides of the equation. So I'm going to get rid of that 3 by dividing everything by 3. Okay, so now we're going to rewrite this as x squared plus 10/3 x, and at the same time I'm going to, well here, let's just minus 8/3 equals 0. So this side still stays 0, and now we're in this situation. So I'm going to add the 8/3 over. Leaving a space for my completing the square. Rewrite this as a perfect square. Half of 10/3, x plus 5/3. Remember, it's either half of the numerator or double the denominator. You're going to get the same as half equals. Now, here's where I'm going to add 5/3 squared to both sides. So add 25/9 to both sides. Okay, so what I did was I took half of 10/3, put it here, squared it, and added it to both sides. Now, before I write the answer, or this side, I'm going to go ahead and add those. So I'm going to do a little bit of side work here. So the side work is going to be 8/3. If I multiply both top and bottom by 3, I get 24/9 plus 25/9 is 49/9. So this side is 49/9. Okay. So what we're going to do is we're going to take the square root of both sides, plus and minus. I get x plus 5/3 equals plus or minus, and this is kind of nice because 49/9 is a perfect square, so it's 7/3. Okay, so then I'm going to subtract 5/3. Always subtract or add to the front of the plus and minus because there's two answers. There's a negative 5/3 plus 7/3, and there's a negative 5/3 minus 7/3. So there's 2/3 and negative 12/3, which is negative 4. There's my two answers. Okay. All right, so that is a problem that we're leading up to. We've kind of built up our concepts up to that point. I've got 3 other examples I want to show you. I want to show you the 5B, 6A, and 6B. And then that'll complete our section for 4-5. Okay, so let's get example 5B on here, and let's work through that. I will try to do this quickly, so you can always pause the video and you can try it before I do, if you would like. So 3x squared plus 14x minus 16 equals 0. 6a is x squared plus 2x plus 2 equals 0. And 6b is x squared minus 6x plus 25 equals 0. Now, like I said, if you would like to try this one right now on your own, pause the video and I'll be going over it here and you can start it back up when you're done to see how you do. Okay, so here we go. Again, since there is a number in front of the x squared that's not 1, we're going to divide by 3 to everything. Leaves me with x squared plus 14x, or 14 thirds x minus 16 thirds. I'm going to add the 16 thirds over. I get x squared plus 14 thirds x equals 16 thirds. And again, I leave a space here. Make it into a perfect square. Half of 14 thirds is 7 thirds, so x plus 7 thirds. I'm going to then add 49 ninths. Remember, you square the 7 thirds to both sides. Okay. To add those two together, I need to go ahead and multiply top and bottom by 3. So that is 48 ninths plus 49 ninths. Just making sure I had my signs right, making sure that was a positive. Okay, so we end up with, let's see, 797 ninths. I'm just going to double check to make sure my sign is correct from the book. Negative 16, yep. So we add that. Take the square root of both sides. Plus or minus. We end up with x plus 7 thirds equals plus or minus the square root of 97 over 3. Okay, you never want a square root in the denominator, and then I'm going to subtract 7 thirds. So my answer is, in simplified radical form, negative 7 plus or minus the square root of 97 all over 3. And that should be the correct answer.